Alright, so as our continuation of previous video, we'll be taking the third question of our series of 5 questions in calculation chemistry. This one is optimized to enable you to solve the question as fast as possible in exam conditions. Alright, question says, how much magnesium is required to react 250 cm cube, that's volume, of 0.5 molar HCl. We said molar represents concentration in mole per dm cube, right? So they give you magnesium is what? 24. Option A says 0.3 gram, B 1.5 gram, C 2.4 gram, D 3 gram. As we did before, the first thing we're going to do is to write out the equation. The equation, that's reaction of magnesium and HCl from acid, base, and salt. Whenever a metal, in this case magnesium, all right, let's write the solution here. So this is our solution. So whenever a metal, in this case magnesium, reacts with an acid, we first need to know the product that I relate. What are the products? Is salt and hydrogen gas. The salt, which is now magnesium chloride, not MgCl, but rather MgCl2 plus hydrogen gas H2, right? Now to balance this equation, we're simply going to put 2 in front of HCl. Hydrogen is balanced, 2 moles of hydrogen, 2 moles of hydrogen, 2 moles of chlorine, 2 moles of chlorine. Now first, we said how much magnesium. The magnesium that they asked us for is in mass. So this is a representation of mass to mole relationship. Why is it mass to mole? Because I can find number of moles of HCl. So right, to find number of moles, so the ratio here is 1:2. So let's divide first. So number of moles of HCl, all right, is equals to, we said number of moles concentration times volume. Concentration, which is now 0.5, times, we need our volume, which is 250 cm cube. We need it in dm cube. So let's put this in bracket. 250 divided by 1000. All right. So we're going to compute that. So we have 0.5 times 250, which is our volume, divided by 1000. Divided by 1000. Put it in bracket. So we have our number of moles as 0.125. So we have, this is equals to 0.125 mole. Now, based on this balance equation, we're going to relate if 24 gram, that is, because this is 1 mole, remember that mole is equal to mass over molar mass as well. So, and we have 1 mole, molar mass is 24. So if 24 grams requires, all right, if 24 grams requires 2 mole of HCl, all right, that's for the balance equation. Now they're not asking us how much magnesium requires 0.125. So that's now, so we say if 24 gram of Mg, you don't have to write this, but I'm just doing it, require 2 mole of HCl, then X gram of Mg magnesium will require how much magnesium require 0.125. So all we just have to do is cross multiply. X will be now equivalent to 0.125 times 24. 0.125 times 24. Then we divide all through by 2. So if I compute this, we're going to have 0.125 times 24, then we divide this by 2, so that's 1.5. so remember that this is in mass, right? That's 1.5 grams, short and easy. 1.5 gram of what? Of Mg. So the correct answer is option B. Moving on to the next question, question 4. How many moles of H plus hydrogen ion are there in 1 dm cube of 0.5 molar solution of H2SO4, which is sulfuric acid? Now, first off, when H2SO4 dissociates, it's going to give us two things, which are hydrogen ion and the sulfate ion. So we're going to actually write out the equation. All right, so let's go. Solution. Dissociation of H2SO4, when it dissociates, will give us 2 moles of H plus 1 mole of the sulfate ion SO42 minus. Now they're asking how many moles of H plus are there in 1 DM cube of 0.5. So this is a mole to mole relationship. We are relating hydrogen ion and sulfuric acid. So 1:2 for the balance equation, right? So 1:2 for the balance equation. And now they ask how many moles of H plus. So meaning we need to find the number of moles of H2SO4. How do we do that? We need to find the number of moles of H2SO4 first. We say that number of moles, which is N, we already did that for question 3. N is equals to concentration times volume. Concentration is 0.5. They give us volume in dm cube times 1. So this is equals to 0.5 mole. So we relate. If 1 mole, alright, if 1 mole of H2SO4 gives 2 mole of H plus, then they are asking 0.5 mole will give, right, x. So simply cross multiply x. Now 1 times x is x. 0.5 times 2, that is equals to 1 mole of H plus. All right, let's move to the next question. Question 5. 4 grams of sodium hydroxide in 250 cm cube of solution contains A. 0.4 moles per dm cube, B. 0.1 moles per dm cube, 0.04 moles per dm cube, 0.02 moles per dm cube. Now, if you had been following before, you know that moles per dm cube is a representation of concentration, which we said can be represented as m molar. Alright, so let's solve solution. So the first thing we want to do is that we actually want to find concentration of the solution, because now that's actually going to be our answer from option A to D. How do you find concentration? We know that number of moles N is equals to CV, right? Now we want concentration. We're given volume in cm cube. We don't have number of moles. So let's find number of moles. Number of moles, which is mass over molar mass, right? So number of moles is mass over molar mass equal to mass was given as 4. As for the molar mass, let's calculate it. NOH, we're given the molar mass of each individual element, but you ought to know that as now. NOH, we have 23 plus oxygen is 16, hydrogen is 1. If you add everything here, you also get 40. So let's impute that here. 4 divided by 40, we're going to get 0.1 as number of moles, right? 0.1 mole. Then what they ask us for? They ask for concentration. If I make concentration, so that's formula, I will have that concentration C is number of moles divided by volume. So number of moles was given to us as 0.1 and volume 250 cm cube. We need to convert 250 cm cube to dm cube. To do that, we just need to divide 250 by 1000. So doing that, we have 250 divided by 1000. That gives us 0.25. We've done that for in previous videos. We established the relationship. So 0.1 divided by 0.25, 0.1 divided by 0.25, that gives 0.4. So if you divide this, you get 0.4 mole per dm cube, and that is our final answer, going as option A.